Hello friends, welcome all of you to my YouTube channel. Today we will discuss different test method for workability of self-compacting concrete (SCC). Self-compacting concrete (SCC) is highly flowable, non-segregating concrete that fill informally and completely every corner of the framework by its own weight and encapsulate reinforcement without any vibration, whilst maintaining homogeneity. A concrete mix can only be classified as self-compacting concrete if the requirement for all the below mentioned characteristics are fulfilled. Four requirement. First is flowability, that is filling ability. Second one is passing ability. Third one is segregation resistance. Fourth one is viscosity. So to match all of the parameters following are some of the test procedure which is recommended by EFNARC. In this video we will discuss test method for workability of self-compacting concrete. The first test will be the slump flow and T50 centimeter test. In every test we will discuss the requirement of equipment, procedure, and lastly interpretation. Similarly, the second test is J-ring test. Third test is B-final test and B-final test at T5 minute. Fourth test is LBox test method and fifth test is UBox test method and sixth test is FillBox test method. Now start with the first test, slump flow and T50 centimeter test. The slump flow test is done to assess the horizontal flow of concrete in the absence of obstructions. It is the most commonly used test and give a good assessment of filling ability. It can be used at the site. The test also indicates the resistance to segregation. When the slump cone is lifted, start the stopwatch and find the time taken for the concrete to reach 500 mm mark on the plate. This time is called T50 time. This is an indication of the rate of spread of concrete. If we talk about equipment required, usually slump cone having a base diameter 200 mm and top diameter is 100 mm and height 300 mm is used, that is a standard slump. A stiff base plate square in a space having at least 700 mm side, concrete circle, a concentric circle are marked around the center point where the slump cone is placed. A firm circle is drawn at a 500 mm diameter. Next, a trowel, a scope, measuring tape, and stopwatch are required as equipment. Here are seeing the plate where the concrete are spreading. If we talk about procedure, about 6 liters of the concrete is needed for this test. This is least amount of concrete that is required. Other tests may get more quantity of concrete or need more quantity of concrete to pursue test. So see the procedure. First, place the base plate on level ground. After that, keep the slump cone centrally on the base plane. After that, fill the cone with the scope but no tamp. Simply strike off the concrete level with the trowel. Remove the surplus concrete, lay on the base plate, raise the cone vertically and allow the concrete to flow freely. Measure the final diameter of the concrete in two perpendicular directions and calculate the average of the two diameters. This is the slump flow in mm. Note one thing, that there is no water or cement paste or mortar without coarse aggregate is seen at the edge of a spread concrete. If we talk about interpretation, the higher the flow value, the greater is the ability to fill framework under its one weight. A value of at least 650 mm is required for SCC, self-compaction concrete. In case of the sewer segregation, more coarse aggregate will remain in the center of the pole of the concrete and mortar and paste at the periphery of the concrete. If lower T50 time, then it indicates greater flowability. Now discuss about second test, that is jarring test. Jarring test denotes the passing ability of the concrete. It is also common test method at site. The bar and sections in this test can be placed at a different distance apart to simulate the conjunction of reinforcement at the site. Generally, these sections are placed 3 times the maximum size of aggregate. The diameter of the ring formed by vertical section of the 300 mm and height 100 mm. Equipment, you are seeing this wall. Now the equipment requires slump cone without foot plates pieces, base plate at least 7 mm square as you have already seen above, trowel, scope, tape, jailing rectangular sections 30 mm into 25 mm plate vertically to follow a ring of the 300 mm dia, generally at the spacing of 48 mm. If we talk about procedure, about 6 liters of the concrete is needed for the test. Moisten the inside of the slump cone and base plate. After that, place the jailing centrally on the base plane and slump cone centrally inside the jailing. Fill the slump cone with a scope. Do not tamp. Simply strike off the concrete level with trowel. Remove all the surplus concrete. Raise the cone vertically and allow the concrete to flow out through the jailing. Measure the final diameter in two perpendicular directions. Note any border of the mortar or cement paste without coarse aggregate at the edge of the concrete. If we talk about interpretation, if the concrete has a good passing ability, then the spread of the concrete with the jailing and without the jailing would be same or absolute maximum difference of the 50 mm in the spread will be observed. Now talk about the third method of test, that is bifunnel test and bifunnel test at T5 minute. Bifunnel test is used to determine the filling ability, that is flowability, of the concrete with a maximum size of aggregate 20 mm size. The funnel is filled with about 12 liters of the concrete and the time taken for it to flow down is noted. After this, the funnel can be filled with concrete and left for 5 minutes to settle. If the concrete shows segregation, then flow time will increase significantly. You are seeing the apparatus. Now talk about the equipment, that is V-funnel, bucket of at least 12 liters, troll, scope, stopwatch. If we take about procedure, about 12 liters of the concrete is needed for this test. Set the V-funnel on firm ground and moisten it from inside and of the funnel. Close the trapdoor at the bottom and place a bucket underneath and then fill the apparatus completely with concrete. No compaction, no tamping to be done. Open the trapdoor after 10 seconds and record the time taken for the concrete to flow through. This can be judged when the light is seen when viewed from the top. The whole test is performed within 5 minutes. Procedure for flow time at T5 minutes. Do not clean or moist the inside surface of the funnel. Then close the trap door and refill the V-funnels immediately after measuring the flow time. Place the bucket underneath. Fill the apparatus completely with concrete without tamping or trapping, and then strike off the concrete level with the top bar trowel. Open the trapdoor again after 5 minutes and allow the concrete to flow, and calculate the time taken for the complete discharge. It is called the flow time at T5 minute. Interpretation. This test measures the ease of flow of the concrete. Shorter flow time indicate greater flowability for SCC, self-compaction concrete. A flow time of 10 seconds is considered appropriate. The inverted cone shape resists flow, and prolonged flow time may give some indications of the susceptibility to susceptibility of the mix to blocking. After 5 minutes of settling, segregation of the concrete will show a less continuous flow with an increase in the flow time. For V-funnel test, the flow time should be between 8 and 12 seconds. For V-funnel, for time at T5 minute plus 3 seconds is allowed. Now talk about fourth method test, that is LBox test method. The test assists the flow of concrete and also the extent to which the concrete is subjected to block by the reinforcement. It is mostly preferred with underwater concrete to be done. Equipment required: L-box of the stiff no observing metals material, and 12 a scope stopwatch that is generally known. If we talk about procedure, about 14 liters of the concrete is required for this test. The vertical section is filled with concrete. Then the gate lifted to let the concrete flow in the horizontal section. When the flow has stopped, the height of the concrete at the end of the horizontal section is expressed as a proportion of that remaining in the vertical section. H2 upon H1. It indicates the slope of the concrete when at rest. This is an indication passing ability or degree to which passage of the concrete through the bar is restricted. Interpretation. The concrete flow as freely as water. At rest, it will be horizontal. Therefore, H2 by H1 will be 1. Unity. Therefore, nearer the test value, the block ratio is to be unity, the better the flow of the concrete, meaning acceptable value of about 0.8 preferred. T20 and T40 time can be give some indications of ease of flow, but no suitable value have been suggested. Now the fifth test or method is UBox test method. The test is used to measure the filling ability of the self-compaction concrete. It consists of a vessel that is divided by a middle wall into two compartments. This is simple test to conduct, but the equipment may be difficult to construct. No, it is not difficult. It provides a good direct assessment of the filling ability. Here is the equipment, U-block, and dimension also. If we talk about equipment, U-block of the stiff non-observing material, towel, scope, and stopwatch. Talk about procedure. About 20 liters of the concrete is needed to perform the test. Moisten the inside surface of the apparatus. Remove any surplus water. Fill the one compartment of the apparatus with a concrete sample level. It to extend for 1 minute. Lift the sliding gate and allow the concrete to flow out into other compartment. After the concrete has come to rest, measure the height of the concrete in the compartment that has been filled. in two places and calculate the mean height h1. Measure also the height in the other compartment, that is h2. Then calculate h1 minus h2, a difference in height, which is also known as filling height, and it should be lower as possible. Interpretation: if the concrete flow as freely as water, at rest it will be horizontal and difference in height will be 0. Therefore, nearer this test value, the filling height is to 0, the better the flow and passing ability of the concrete. Now the sixth method is filling box test method. The test is used to measure the filling ability of self-compacting concrete with a maximum aggregate size of the 20 mm. It consists of container transparent with a flat and a smooth surface. A container is filled with a concrete through this filling pipe, and difference in height between two sides of the container is a measure for the filling ability. Even a concrete mix with a high fill ability will perform poorly if passing ability and segregation resistance are poor. It is complex and difficult to perform one side, hence no used commonly. Here the apparatus equipment: fill box of stiff, transparent and no observing material, scope 1.5 to 2 liter, ruler and stopwatch. If we talk about procedure, about 45 liters of the concrete is needed to perform the test. Moisten the inside surface of the apparatus, remove any surplus water, fill the apparatus with concrete sample. Then fill the concrete by adding even 5 second one scoop with 1.5 to 2 liter of the fresh concrete into the funnel until the concrete has just covered the first top extract. Measure after the concrete has become to rest the height at the side at which the concrete is filled in two places and calculate the average h1. Do this also on the opposite side h2. Calculate the average fill percentage of the average filling. Interpretation: if the concrete flow as freely as water at rest, it will be horizontal. So the average filling percentage is equal to 100%. Therefore, neither this test value, the filling height, is to 100%. The better the self-compacting characteristics of the concrete. Thanks for watching this video. We will meet again with another topic.